Okay, so in this video we're going to solve the equation 2 cosecant of x minus 2 equals 1 over sine of x, and we want to find all of the solutions from 0 to 2 pi and check them in the calculator to make sure that they're correct. So the first thing we want to do is jot down that trig identity hexagon that we learned about in previous lessons. And that'll help us recall the fundamental identities. So tangent, cotangent, sine, cosecant, cosine, secant, and the center always gets a 1. Okay, so looking at what we're given here, we've got 1 over sine of x and a cosecant. Sine of x is a reciprocal of cosecant. We can see those reciprocal relationships on the diagonals here. So sine's reciprocal is cosecant, cosine's reciprocal is secant, tangent's reciprocal is cotangent. So if I use that reciprocal identity, then I'll have 2 cosecant of x minus 2 is equal to cosecant of x. And the reason I chose to do that was because typically you want to try to get the same trig function throughout your equation if possible. That just makes it a little easier to work with. So in the next step, now we're going to go ahead and combine some like terms here. So if I subtract cosecant of x from both sides, then I have 2 cosecant of x minus 1 cosecant of x. That's equal to 1 cosecant of x. Then there's a minus 2, and then that's equal to 0 because cosecant of x minus cosecant of x is 0. Okay, and when I look at this cosecant of x minus 2, there's nothing squared there, so I can't use a Pythagorean identity. I just want to get this x by itself. So let's go ahead and start moving things away from the x. So if we add 2 to both sides, then we have cosecant of x equals 2. And then we're going to go ahead and do that same reciprocal identity now to get back to sine. Because I don't have cosecant values from the unit circle memorized. If you do, feel free to take the arc cosecant at both sides at that point, but I don't, so I'm going to go ahead and change that cosecant back into its reciprocal, which is sine. So 1 over sine of x is equal to 2, and then I can cross multiply. 2 sine of x equals 1, divide both sides by 2, and sine of x is 1/2. So I do know my sine ratios for the unit circle. So at this point, I'll go ahead and take the inverse of both sides to get x by itself. So x would be equal to the arc sine of 1/2. And then on my unit circle, I'm going to go ahead and sketch the first quadrant of the unit circle using that shortcut that we learned earlier in the year. So this is 0 radians, pi over 6, pi over 4, pi over 3, and then pi over 2 along the positive y-axis. And each of these radian angles has an ordered pair that goes with it. And the shortcut for filling in those ordered pairs in the first quadrant is we start on the outside here with the y, and we go 0, 1, 2, 3, then back to 1, 0, 1, 2, 3, and back to 1. Okay, and the quadrantal, there's my 1, 0, and my 0, 1. In the middle, I square root all of these values, so square roots on top of everything. The square root of 1 is just 1, so I don't bother putting square roots on those, and then everything gets divided by 2. And now I've got all of my coordinates for the first quadrant filled in. So if I want to find where the sign is positive 1/2, I look for for y values in the coordinates, because sign is the y value, the x coordinate is the cosine. So when I take a look at this first quadrant, I see right here at pi over 6, I have a y value of 1/2. So that's going to be my first solution. X is equal to pi over 6. Okay, now if you recall the acronym for remembering the quadrants, all students take calculus. That helps me remember where things are positive, because I know the A stands for all positive in quadrant 1, and that's where I found my first solution. So I know that that first solution from quadrant 1 is right here at pi over 6. But where else is there a positive sign? Well, S in that acronym, all students take calculus, S stands for sine and its reciprocal cosecant being positive in quadrant 2. So I'm going to find my other solution by reflecting this reference angle into quadrant 2. So if this is pi over 6, then half of the circle would be 6 pi over 6, and back one would be 5 pi over 6. So x equals 5 pi over 6 is my second solution to this equation. So now we're going to go ahead and check those answers in the graphing calculator by first making sure that we're in radian mode. And then we're going to store pi over 6 into the calculator. So I'll just lift this up so you can see it a little better. So second, and then pi divided by 6, store x, and press enter. And even though the calculator shows a decimal approximation, it knows that we wanted that exact value to be put there. And now we're going to check it in the original equation that we were given. There's no cosecant button on the calculator. There's only sine, cosine, and tangent. So we're going to need to use a reciprocal identity to check that cosecant. So we're going to do 2 and then divided by sine of x, because the reciprocal of cosecant is sine. Then minus 2, second math, number 1 to get the equal sign, and then 1 divided by sine of x for the other side. Whenever you use that equal sign in the calculator, you're asking it a question, a test question, to test whether substituting in that x value, that pi over 6, is going to produce a true statement. If so, the calculator returns a 1 for yes. If false, it returns a 0 for no. So we press enter and we get a 1, and so we know that this answer checks. Okay, now we're going to check the second solution, which is 5 pi over 6. We're going to store that as the new value of x, and then instead of typing over that equation again, we're just going to arrow up to it, press enter, and the calculator retypes it for us. And again, we got a 1, which means that 5 pi over 6 also checks. And we found all the solutions from 0 to 2 pi for this trig equation.